Welcome all. So myself Sasikumar, so Assistant Professor in Department of Civil Engineering, so Builders Engineering College. So today we are going to see about an overview of fluid mechanics. So what is fluid mechanics means? The study of behavior of fluids in different conditions. See, this is just an objective of the fluid mechanics. So in this, how fluid is behaving in different types of conditions, we are going to see that in flow measurements. So flow through pipes, so laminar flow, turbulent flow. So based upon the Reynolds number, the laminar and turbulent will be classified. So pipe bends and how it is exposed to boundary layer. So boundary layer we are going to see about in detail in upcoming units. Next slide. See here, just we are going to study about the fluid properties. So fluid properties like density, viscosity, so surface tension, so capillarity, compressibility. See, these are some of the properties we are going to see in detail. By using continuum concept, we are going to study these type properties and all. So next, fluid statics. So what is the difference between fluid statics and fluid dynamics and kinematics in the sense? When we study the fluid at rest, this comes under fluid statics. Suppose if the fluid is at movement, the movement takes place due to application of external force, means it comes under fluid dynamics. If an external force is applied for movement takes place, that comes under fluid dynamics. So if we are not applying any external forces, for example, if the fluid is flowing through the gravity, this comes under fluid kinematics. So just we are going to see about fluid statics here. So under that manometry, what are the equipments we are going to measure the pressure, these things and all we will cover in this unit. So next, buoyancy, flotation, stability of floating bodies. Buoyancy in the sense the upward force offered by the liquid surface when an object is immersed in a liquid. So metacenter, the point about which the object rotates when it is disturbed. These things and all detailedly we are going to study in the first unit. So in second unit, as I have already told, fluid kinematics and fluid dynamics. If a force movement of fluid takes place without application of external forces, it comes under fluid kinematics. In this, we are going to study two things. One is classification of flow. So under classification flow, we have steady flow, unsteady flow, laminar, turbulent, rotational, irrotational. So these are few of the flows we are going to study here. So next, streamline, streak line, path line. These comes under lines. So stream function and velocity potential functions. Flow nets is nothing but a drill to obtain when a velocity potential and stream functions join together. So these detailedly we are going to study in fluid kinematics. Next, fluid dynamics. So using control volume approach, we are going to see these dynamic concepts. Under that, we are going to see about Bernoulli's equation and Euler's equation. So before that, what are the different kind of force acting on the fluid, we are going to see. Based upon that, we will have Bernoulli's equation and Euler's equation. So next, application of Bernoulli's equation, we have three types of application. One is venturimeter, orifice meter and pitot tube. We are going Bernoulli's applications. So pipe bends, moment integral equations. So these we will elaborate in upcoming units. So dimensional analysis and model studies. So here we will detailedly study how an object depend upon other variables. For example, if a discharge equal to area into velocity means, so Q is nothing but a dependent variable. It will depend upon area and velocity, while area and velocity is an independent variable. So it will act, it will not vary when a discharge will get varied. So these things we are going to detailedly study in dimensional analysis. So Rayleigh method and Buckingham by theorem. So we have some demerits in Rayleigh method, so which will be overcome in Buckingham by theorem. For example, if there is more than 3 unknowns, we can solve any equations in Buckingham by theorem. This we cannot do it in Rayleigh method. So these then similitude model studies. So disorder model and disorder model. So model in the sense, whatever the thing we are making model to study the properties is called as a model object. Prototype is nothing a real model, real type examples. So incompressible viscosity flows. So here we are going to see laminar flow and turbulent flow. So how the fluid behave in laminar and turbulent flow. So major loss and minor loss, these things we are going to see here. So major loss, only friction loss comes under major loss. So in minor loss we have more number of losses like contraction, so expansion, so pipe bend. So these things comes under minor losses. So energy line, hydraulic line, using these concepts, that is losses, we are going to study this energy line and hydraulic line. So pipe in series and pipe in parallel. So when we need more amount of discharge, so we have to connect the pipe in series. parallel. If we need more amount of head, so like if we want to discharge the water through high-rise building, we have to connect the pipes in series. So these how losses will affect this pipe in series, pipe in parallel, we are going to see this in detail. So next, boundary layer. If an object is